Okay, let's graph some trig functions here. First off, this is theta, so I'll be in degrees versus x in radian. So I have a 5-step process to make this graphing pretty easy. Step 1, mark up the equation. So right here I have an example. Here's my general equation, y equals c plus a cosine b theta minus d. And then here's an example. So when I say mark up equation, grab another pen here. I want to say what every one of these variables is. 5 is vertical, 3 is my amplitude, 2 gives me my period, so 360 divided by 2 is my period of 180, and this 90 is my phase shift, so that moves it over. So step 1, mark up your equation. The next step is label the y-axis. So from 5, I go up 3 to 8 and down 3 to 2. So step 2 is label the y-axis, and that includes your C and A values, the vertical shift and the amplitude. There it is, so that's my y-axis. Step 3 here is label the x-axis. That uses this and this. So on my horizontal axis, I start at 90. I end 180 degrees later at 270. Halfway between here and here is 180. So I get plus 90 plus 90. Then I need my quarter points. So half of 180 is 90. Half of that is 45. So my first quarter is 45 after 90. So 135 plus 45 plus 45 plus 45. So I split it into 4 equal quarters. Step 4 is find my critical points looking at the function. So it's a cosine. So a cosine starts at a high point, ends at a high point. In the middle, it's at a low point. At the first quarter, it's in the middle on the y, and the third quarter, it's at the middle on the y. Connect those critical points, and there's my cosine graph. And finally, step 5 is to check. I'll just pick a value like 140, 180, pick a value like 180, and plug it in. 180 minus 90 is 90, times 2 is 180. Cosine of 180 is negative 1. Negative 1 times 3 is negative 3. Plus 5 is 2. So at 180, I should be at 2, and I am. So that's how easy it is with this 5-step process to graph your trig functions. Again, this theta right here tells you I'm in degrees. If this were an x, I would be in radian measure, and I'd be using 2 pi instead of 360.